Hello everyone, welcome to our PBL Level 1 Physics project. Today we're going to talk about friction. Alright, what is friction? Before friction, like what friction is, do we need friction? Is it a good thing? Is it a bad thing? Well, most people probably think that friction is a bad thing because you're going to lose a lot of energy due to friction. So this is the reason why that you are not able to get 100% efficiency from the gas that you're using. So there are a lot of places that you are actually having problem with the friction. And as a physics teacher, I also hate friction sometimes because most of the time students are answering the questions as like the answer to the question. Most of the questions that I ask to them is friction or gravity. So sometimes I'm like, everything is not friction. But do we really need friction? And actually, if we really think about it, friction is the cause that we are here. So if there were no friction, there would be no life. Because friction is the reason that everybody or everything or all of the molecules are sticking to each other. There is a force in between the surfaces. If there were no friction, then there wouldn't be any force in between the surfaces. So you wouldn't be able to walk. Because the reason that you're able to walk is the force that you apply on the surface, and because of the friction, that force is going to be pushed forwards, action-reaction principle. So this is how you're walking. If there were no friction, you wouldn't be able to walk. So friction is actually a very important concept, and we definitely need friction in our lives. And today we're going to talk about how to find the friction of a surface, or more specifically, coefficient of friction, because every surface have different amount of frictions, which we call them or define them as coefficient of friction. So today we're going to talk about how to find the coefficient of friction of a surface. To be able to do the experiment, we're going to need a Pascal force sensor, and we're going to need a friction block, a Pascal USB link, and 6 of the mass blocks of Pascal, which is 250 grams of each. And we're going to need Pascal capstone software for us to be able to use our sensors. First, we're going to plug in our USB link to the computer and make sure that it's connected, and you need to see the green light over here. After we plug in our USB link to the computer, we're going to connect it to the force sensor. Now our sensor is connected to the computer. Next, we're going to have our friction block, and then we're going to place a 250 gram mass. And next, we're going to connect our force sensor to the block. And now our setup is ready. And on the capstone, we're going to open the table and graph. So when you double click on the table and graph, you're going to have this. And on the y-axis, we're going to need to have the force. And on the x-axis, that is going to measure the time. And what we're going to do is very simple. So we already have the mass on the cart. So we're going to pull the force sensor, and that's going to measure the force. But it's very important that we are going to pull this cart with a constant speed. If we do not do it with a constant speed, then our data is going to be wrong. So it's very important that you are pulling this cart with a constant speed. All right, so we're going to start recording data. And we got to make sure that everything is set. And we got to make sure that we are zeroing our sensor. All right, force sensor is so sensitive, so you don't need to worry about the up and downs in the screen. All right, so I am starting to pull it. And that's our first data. And after we have the data, what we need to do is, as you can see over here, this section is basically the place that we were pulling it with a constant speed. So what we're going to do is we're going to get the average of this section only. And how are we going to do this? Over here you have the option that you can get the minimum, maximum, mean value, and then standard deviation. And we're going to use the mean value that's already selected. So if you click on this, it is going to tell you the average of the entire data. But we don't need the average data of the entire data. So what are we going to need? We're only going to need this section. And for this, on the top left, you already have the highlighter. So if we highlight the area that we are trying to find the average of, you just need to select this section. So right now this is my highlighted area, and I'm going to drag this to this section, and you can click on the screen and then you can move it anywhere that you want. So, and after you click on the screen, the highlighted area, you can also change the size of it. And I'm only going to need this section and this section. So that is going to give my average data for the force that I was applying on the box. And basically this is going to be the force of friction that is acting on the box, because the only force that is acting on the box, on the cart, is the friction. So, and that force is basically measuring that force. And this is going to be 1.2. That's negative, but that doesn't really matter. It's only depending on push or pull. So since we're pulling, it sees it as negative. So it's not a big deal. And we're going to have this data over here as 1.2. And this is going to be my friction force. And I'm going to rename it as friction force. And my unit for this is Newton. All right, next we're going to add one more block. And then we're going to repeat the experiment again. So for this, we just need to record a new data. So start a new data. And then, again, you're going to pull it slowly and with the same speed. And we're going to do the same thing. We're going to have a highlighter. So we're going to select this data. And this is going to be the region. And my average for this part is 2.3 newtons. And we're going to do the same thing again. Now we're going to add our third block. And then we're going to do the same thing. We're going to pull our force sensor with a constant speed. But of course, we need to start recording data. And then pull it slowly and gently, but with a constant speed. All right, and we need a highlighter. And this data, as you can see, if you don't pull this like slowly, your data is a little bit off. So I'll take this part since it's going up and down. So that's going to give the average. So that is going to be 3.6. Now we're going to add the fourth block into the card, and then we're going to record data and do the same thing. And the highlighter. That's a little bit better than the others. And my average for this is 4.8. All right, now we're going to try the fifth mast. So we're adding the fifth mast, and then we are going to record our new data. And we're going to pull our card gently and slowly. data and highlight the area. And that's going to be 6 newtons. All right, now we're going to try the last mass, and it's going to be our 6th mass. And we're going to record data and pull our force sensor. And highlight the region. And that's going to be 7.1. All right, now we're going to analyze the data. So we have our friction forces, and to be able to analyze data, to be able to find the coefficient of friction, first we need to know the equation. And equation is as follows. Friction force is equal to mu times normal force, and over here friction force is the force that we were pulling, so this is the data, this is the number that we were reading from the sensor, and we are trying to find the mu. So if we add the mu over here, if you want to solve it for mu, then equation, our mu is going to be basically friction force divided by normal force. And what is our normal force in this case? Normal force is going to be the mass of the cart, the weight of the cart, and since we only have the mass blocks on our cart, then the weight of those masses is going to be our normal force. So it's going to be mu equal to friction force divided by mg. And this m is going to be the masses of the carts. So, and since we know all of the masses are 250 grams, we are going to know that mg of the masses is going to be 250 grams times gravity. So, and in this case, it's going to be 0.25 times gravity. So if we take gravity as 10 slightly, then our mass weight is going to be 2.5 newtons. And this is our normal force for the first cart. And we are going to be adding the same mass blocks each time. So we're going to increase it by 2.5 newtons. So this is going to be our mg data, and we are just going to add 2.5 newtons for each. It's going to be 7.5, 10, 12.5, and 15 newtons. So this is the friction force, and this is my mg data. So I want to rename it, and that's going to be mg data. And the unit for mg is also Newton. So now I am going to need, as we see over here, mu is the friction force to mg ratio. So if we plot the friction force to mg data, then the slope is going to give me mu. What I'm going to do is, on the x-axis, from the same graph again, on the y-axis I need to have the friction force. So my data is going to be friction force, and on the y-axis I'm going to have the mg data. So if you plot this, I still have this mean. I don't need this mean. All right, so this is my data. And as you can see, this is a pretty good flat data, and that's what we're expecting, because as mg increases, friction should increase, and that should be a linear proportion. So if we get the slope of this data, and this is going to be my coefficient of friction. So this is going to be, from the scroll down menu, you need to go linear MXB, and that is going to give you your slope. And your slope in this case is 0.478. So this is the coefficient of friction of this surface and the table. So now we're done with our experiment. All right, we found the coefficient of friction, but why do we need the coefficient of friction? It's really important in our daily life. For example, in snow, we have snow tires. So they need to be able to find the coefficient of friction in between the tire and the snow so that we can have safe tires. So that's how important coefficient of friction is. And that's it for today, and thank you for watching. See you next time.